Pulling a phone wire with line voltage is against the National Electrical Code and other electrical codes. This is because the high voltage can induce electrical current into the phone wire, creating a safety hazard. To meet code, install a separate conduit or raceway for the phone wire. Since trenching is not feasible, consider surface-mounted conduit or flexible conduit. Firstly, surface-mounted conduit involves installing a metal or polyvinyl chloride conduit in the exterior or interior walls of the garage. Secondly, flexible conduit utilizes a flexible metal conduit or a liquid-tight flexible metal conduit that can be fished through existing raceways or holes. Even if you follow code and install a separate conduit for the phone wire, there is still a potential for interference from the nearby line voltage. To minimize this, use a shielded cable designed for use in high-voltage environments. Shielded cables have an outer layer of conductive material that helps block electromagnetic interference. The safest and most code-compliant approach is to install a separate conduit or raceway for the phone wire. While shielded cable can help reduce interference, it may not completely eliminate it. Therefore, it's best to avoid running phone wires in close proximity to line voltage if possible. If you are unable to install a separate conduit, consider using a wireless phone system or a cellular booster to improve signal quality in the garage. Electrical codes, such as the National Electrical Code, exist to protect people and property from electrical hazards. These codes are developed and maintained by organizations like the National Fire Protection Association and are adopted by local jurisdictions. Adhering to these codes ensures that electrical installations are safe and reliable. When dealing with electrical wiring, it's crucial to understand the different voltage levels involved. Line voltage, typically 120 volts or 240 volts in residential settings, is used to power appliances and lighting. Phone wires, on the other hand, carry low voltage signals for communication. Mixing these voltage levels in the same conduit creates a dangerous situation. High voltage can induce current into the low voltage phone wire, potentially causing electric shock or fire. Different types of conduits are available for electrical installations, each with its own advantages and disadvantages. Metal conduits, such as rigid metal conduit and intermediate metal conduit, provide excellent physical protection and are suitable for both indoor and outdoor use. Polyvinyl chloride conduits are lightweight and corrosion resistant, making them a good choice for underground installations. Flexible metal conduits and liquid-tight flexible metal conduits offer flexibility and can be used in tight spaces. Shielded cables are designed to minimize electromagnetic interference, which can disrupt the performance of electronic devices. These cables have a conductive shield that surrounds the inner conductors, blocking electromagnetic radiation. The shield is typically made of braided copper or aluminum foil. When using shielded cables, it's important to properly ground the shield to ensure that it effectively blocks interference. Grounding provides a path for unwanted currents to flow to ground, preventing them from affecting the signal carried by the cable. Wireless phone systems offer an alternative to traditional wired phone systems. These systems use radio waves to transmit signals between the base station and handsets, eliminating the need for physical wires. Wireless phone systems can be a convenient option when it's difficult or impossible to run new wires. Cellular boosters can improve cell phone signal strength in areas with weak coverage. These devices amplify the signals received from cell towers, allowing for better voice quality and faster data speeds. Cellular boosters can be a good solution for garages or other locations where cell phone reception is poor. When working with electrical wiring, it's essential to follow all safety precautions to prevent accidents. Always turn off the power at the circuit breaker before working on any electrical circuits. Use insulated tools to avoid electric shock. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the job. The National Electrical Code Article 300.3 covers requirements for conductors of different systems. It states that conductors of different systems, such as power and communication circuits, shall not be installed in the same raceway, cable, or enclosure unless specifically permitted by the code. This rule is intended to prevent the potential for high voltage from the power circuit to energize the communication circuit, creating a safety hazard. Exceptions to this rule are permitted in certain cases, such as for specific types of equipment or where the conductors are separated by a barrier. However, in general, it's best to keep power and communication circuits separate to ensure safety. Article 725 of the National Electrical Code covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are used for a variety of applications, such as controlling lighting, security systems, and fire alarms. Class 1 circuits are power-limited circuits that operate at up to 30 volts alternating current or 60 volts direct current. Class 2 and Class 3 circuits are even more limited in power and voltage. These circuits are designed to be inherently safe and do not require the same level of protection as power circuits. Article 800 of the National Electrical Code covers communication circuits such as telephone, data, and cable television circuits. These circuits are typically low-voltage circuits that carry signals for communication purposes. Article 800 specifies the requirements for installing and protecting communication circuits, including the separation of these circuits from power circuits. The National Electrical Code also provides requirements for grounding and bonding electrical systems. Grounding is the process of connecting electrical equipment to the earth, providing a path for fault currents to flow to ground. Bonding is the process of connecting different metal parts of an electrical system together, creating a low-impedance path for fault currents. Proper grounding and bonding are essential for safety, as they help to prevent electric shock and fire. When installing electrical wiring in a garage, it's important to consider the environment. Garages can be damp or humid, and they may be exposed to chemicals or other corrosive substances. Use wiring and equipment that are suitable for the environment. For example, use corrosion-resistant conduit and fittings in damp locations. Also, protect wiring from physical damage by installing it in conduit or raceway. If you're running wiring underground, use underground rated cable and bury it at the proper depth. The depth requirements are in the NEC. When installing electrical outlets in a garage, use ground fault circuit interrupter outlets to protect against electric shock. Ground fault circuit interrupter outlets are designed to trip when they detect a ground fault, which is a condition where current is flowing to ground through an unintended path. These outlets can help to prevent serious injury or death from electric shock. If you're installing lighting in a garage, use energy-efficient light bulbs to save money on your electricity bill. Light-emitting diode light bulbs are a good choice, as they are very energy-efficient and long-lasting. Also, consider using occupancy sensors to turn lights off automatically when the garage is not in use. This can further reduce your energy consumption. When working with electricity, it's important to be aware of the potential hazards and to take the necessary precautions to protect yourself. Electricity can be dangerous if it's not handled properly. Always follow the National Electrical Code and other applicable codes and standards when installing or working on electrical systems. If you're not comfortable working with electricity, hire a qualified electrician to do the job. Remember, the National Electrical Code is updated every 3 years, so it's important to stay up to date on the latest requirements. You can purchase a copy of the National Electrical Code from the National Fire Protection Association or from other online retailers. You can also find information about the National Electrical Code on the National Fire Protection Association website. Understanding and following the National Electrical Code is essential for ensuring the safety and reliability of electrical systems. By following the code, you can protect yourself, your family, and your property from electrical hazards. In summary, pulling a phone wire with line voltage is a dangerous and code-violating practice. The recommended approach is to install a separate conduit for the phone wire, considering options like surface-mounted or flexible conduit. Shielded cables can help mitigate interference but may not eliminate it completely. If a separate conduit is not feasible, explore wireless phone systems or cellular boosters to improve signal quality. Always prioritize safety and adhere to the National Electrical Code when working with electrical wiring. The NEC provides detailed guidelines for safe electrical installations, covering aspects such as conductor separation, grounding, and environmental considerations. Stay informed about the latest code updates and seek professional assistance if needed. Remember, electricity can be dangerous, and proper precautions are essential to prevent accidents and ensure the safety of people and property. By following these recommendations, you can ensure that your phone wiring installation is safe, code compliant, and reliable.